Hello everyone, I wanted to take a minute this morning and work on a little bit of binomial probability. This is from section 6.2, so we're working in binomial probabilities, and I want to crunch through how to work these using the formula in order to complete this homework problem. So this tells us that we have an n value, or a number of trials, equal to 6. We have a probability value, or p-value, of 0.8, and p in binomial probability is the probability of a success if we only have one trial. So then we are looking to fill out this table here. Now rather than me write in little tiny type, I'm just going to make a bigger table so that we will use each one. I'm also working this problem with the TI-30XS rather than the big TI-84. I know some of you have the TI-83-84 and you can watch the tech help videos for that, but the TI-30XS will also do this type of probability, so I want you to see that as well. Alright, so as far as the binomial probability, probability of a certain number of successes is equal to the combination n combination x times p to the x power times either q or 1 minus p to the n minus x. So you could see this in alternate form. Either way, it works the same way. So x is your number of successes. And we're going to go through and we're going to calculate the binomial probability of each one of these successes here to make the table. So if I'm looking for the probability of 0 successes, then I want the combination of 6 things taken 0 at a time times p is 0.8, so 0.8 to the power of the number of successes, so 0.8 to the 0 power, and then q, or 1 minus p, is 0.2, and n minus x gives me 6 minus 0. As far as this combination is concerned, you should get this out of your calculator. If you are using an 8384, it's the math and then scroll over to probability and you'll find that value. For something like the TI-30, you put in the first number, so I'm entering 6 in my calculator, and then I am pressing the probability button. It is PRB on the front of the screen, and you have choices 1, 2, and 3. The combination is choice 2. So I'm hitting choice 2, and then I put in my 0 component. So 6 combination 0 gives me 1. So I have 1. 0.8 to the 0 power is also 1, and 0.2 to the power of 6. So multiplying this, 0.2 to the power of 6 gives me 0.000064. Generally speaking, this says round to 4 decimal places, so this would round to 0.0001 to 4 decimal places. So we'd round this one up to 1 because of the 6. Similarly, if I change this to the probability of 1, the things that change are now I have the combination of 6 and 1 times 0.8 to the first times 0.2 to the 6 minus 1 or to the 5th. The powers of your 2 decimal components should always add up to your sample size or your number of trials. So if I have 1 in the first one, I have to have 5 in the second one. Looking at my calculator, the combination of 6 and 1 gives me 6 times 0.8 times 0.2 to the 5th. I'll give you some parentheses to make it easier to see. And I get 0.0015. I'm going to go through and just do the setup and then put the rest in my calculator. So the probability of 2 would be the combination of 6 and 2 times 0.8 squared times 0.2 to the fourth so 15, 0.8 squared, 0.2 to the fourth, when I go to enter that here, I am working right through the parentheses, so pretty much exactly the way it appears, and I get 0.0154. Be careful on your rules of rounding here. They should follow traditional rules of rounding. And continuing on, 6 combination 3 is equal to 20 times 0.8 to the third times 0.2 also to the third. Now, since the probability is 0.8, that means that as we go on, we should expect these to increase. So 4 should be more than 3 was. Zero 0.2458, and we have 2 more. So the probability of 5 is 6 combination 5 and times 0.8 to the fifth times 0.2 to the first. I'll write out the 6 as well. That's to the 0 power. It's 3932. And the last one, 6 combination 6 is 1. The last one simplifies really to 0.8 to the 6th power, 0.2621. I hope you find this helpful, and let me know if you need any further assistance with this or problems like it. Thank you.